Welcome to Lesson 6 for Section 7 of the BJCP training program from the Brewers Anonymous Homebrew Club. We are continuing to discuss water, and in this session, we're going to talk about modifying water. All right, I am going to start off saying that I have stated more than once in this section that water chemistry is a huge subject. It could easily be a program that matches the length of this program very easily. And a lot of that material would come from this subject of modifying water. We are not going to get into any real amount of detail of modifying water. This is going to be a very broad stroke covering of the aspect of modifying water. Again, this is not a water chemistry course. This is not a how to brew course. We're only covering what might be on our entrance exam. And with that preface, let's get started. We are starting off the section of this program with a statement that's worth repeating at this point. Water comprises 85 to 95% of your beer. To get that beer to the look, aroma, and taste that we intend, we want to get our water right. We don't want too soft or too hard water. We want to hit a specific pH measurement, and we may want to add some specific minerals to enhance the specific characteristics of our beer. The first thing we'll need to know is what we are working with in terms of our water. If we're working with a specific water source, we'll want an analysis of our water to know exactly what's all in it. And we can get that information several ways. The most accurate information we'd be able to get is to send a sample of our water to a lab for analysis. For a fair fee, we can send a vial of our water to a lab and have the results of what our water is comprised of sent back to us. From that information, we'll know what to do to our water to get it exactly the way we want it. If we're on city water or some municipal provided water supply, we can request a water report of the water they are supplying. With this information, we can again adjust our water accordingly. This can be tough to get sometimes if the information isn't already published to the public, but it's still an option, though you might have to be a bit of a squeaky wheel to get it. We can also buy a testing kit and get the information ourselves. Now, typically, these kits are expensive, the supplies expire relatively quickly, and it's a pretty involved process. However, done correctly, it can be as accurate as a professional lab analysis. I actually do have one of these, and I can add. It's actually kind of fun to do. At least I find it fun. Now that we know what we're working with, we can start to dial in our water to meet our exact needs for the beer we're going to brew. We're going to almost treat our water like any meal we're cooking. A dash of this, a pinch of that, a little bit of some specific additions to get those right enhancements and balance. So now, we are going to talk about the most common additions put in brewing water. These, of course, are not the only things we can add, but once again, we are approaching this in terms of what we need to know for our exams. So we will be looking at calcium chloride, gypsum, Epsom salt, sodium chloride, baking soda, chalk, and lactic acid. So let's start at the top of that list with calcium chloride. Calcium chloride can do several things for our water and in turn for our beer. First, it lowers mash pH. The calcium ions react with the phosphate ions from the malts and produce a slight acidification. It can help increase hop bitterness. As with malts, the calcium ions also react with certain compounds in hops, enhancing the extraction of those alpha acids that are responsible for bitterness. Calcium chloride also aids in clarity. It helps precipitate proteins and polyphenols so that they can drop to the bottom of the boil kettle and the fermentation vessel, leaving clear beer to be transferred into its final serving vessel. Calcium is essential for yeast metabolism and cell wall health. Both contribute greatly to efficient fermentations. It also aids in yeast flocculation. This is the clumping together of the yeast so it falls to the bottom of the fermentation vessel, adding further to the beer's clarity. And calcium chloride can enhance malt flavor and mouthfeel. Chloride ions particularly enhance the perception of malt sweetness and fullness in beer. Now let's take a look at gypsum. Similar to calcium chloride, gypsum adds calcium ions that react with the phosphates from the malts and lowers the pH. The sulfate ions in gypsum can accent hop bitterness, making it more pronounced. It can also enhance the perception of hop aroma, making hop-forward beers like IPAs and pale ales more aromatic. Sulfate ions again help out by precipitating proteins and polyphenols in the wort and help clear the beer. Along with that, it can also contribute to a better foam stability by interacting with certain proteins in the beer and aid in head retention. Gypsum also lends to a creation of a drier, crisper finish in the beer. Next up is Epsom salt. Epsom salt also helps contribute to accentuating hop bitterness by increasing the sulfate level in water. Epsom salt contributes an addition of magnesium, which is an essential nutrient for yeast health. This addition can help ensure healthy yeast growth and fermentation. And in moderate concentrations, the magnesium in Epsom salt can contribute to a subtle enhancement in malt complexity and flavor. Now, something everyone probably has on hand, brewers or not, sodium chloride or table salt. Now, non-iodized table salt specifically in this case. The sodium ions specifically can accentuate the perceived sweetness of malt flavors. It can also make the beer seem fuller and rounder. The chloride ions in this case contribute to a smoother, softer mouthfeel, balancing out any harshness or astringency from other minerals or ingredients. In very low concentrations, sodium chloride can subtly enhance the overall flavor complexity of a beer. Now, there's a couple downsides with adding salt. The first, it's very easy to overdo and make a distinctive salt addition flavor enhancement to your beer. Apart from a Gosa, this is typically not a favorable flavor addition to a beer. Also, and very importantly, an excessive salt addition can stress yeast cells, leading to the production of off flavors during fermentation. Another ingredient in most homes, baking soda. The primary function of baking soda in terms of brewing is to raise the pH level of the mash. There are some considerations when using baking soda to modify water. First is that baking soda contains sodium, which can impart a salty flavor if used excessively. And as with sodium chloride, those sodium levels in baking soda, if used in excessive amounts, can stress out our yeast cells. Now let's take a look at chalk. Chalk has a pretty limited role in beer brewing. It's typically used to raise the pH level of the mash. There is a physical characteristic of chalk that brewers need to be aware of, and that is that chalk has a limited solubility in water. It doesn't dissolve easily. This can make it difficult to accurately calculate and control the amount needed for pH adjustments. And now finally, lactic acid. Much like chalk, lactic acid also has a pretty specific role in water adjustments, and that is to lower the mash pH. It can also be a flavor contribution by adding direct sourness to our beer. Using these properly in adjusting our water for our specific beer that we are brewing takes a lot more information than we're presenting in this lesson. It also takes a lot of research and many times a lot of trial and error. If this is something you're interested in learning more of, there is a ton more information available, including the water book that I think is now the third time I've mentioned this in this course to set you in the right direction. But in purposes of our exam preparation, these are the things we need to know. And this brings us to the end of this lesson. So let's move on to that next lesson on water, and I'll see you there.